So I'm going to quickly go through just to show you how to do the torsion experiment. I'm doing it for one of the pipe cross sections. This will obviously be repeated for each of the different sections, but just to help with showing how the experiment is set up, we'll go through it once. So if you can see the end I'm looking at now, which has the compass, that end is free to rotate, but it is fixed to the table so it doesn't slide. If I go across the other end, that's the opposite, that it's not free to rotate, but it can slide forwards and backwards. This is to allow the different pipe sections to fit on and still be at the same 1.5 meter length, just to make them more easily compared. So what you're going to want to do is loosen off these bolts as much as possible. This is going to allow it to slide more easily. And I'm just going to put the camera down so I can go through it. So the first thing you want to do is you want to get the pipe and you want to put it onto the end that's fixed to the table. And then take the other end and slide it forward until it sits nicely over, until the pipe sits nicely over it. You're then going to take the pins, and it might take a couple of goes just to get them to line up properly. I usually drop it into the top one once and then come from the bottom. That's just to sort of try and get everything to line up as good as possible. Again, it may take a couple of goes, but it will come through. So I just put the nut on just to stop it from moving. You don't want to tighten that end up yet, just because it'll make it a little bit more difficult to put the other end in if you do. Now this end is the free to rotate, so you're going to want to rotate that support around until the holes line up. Again, you want to put it through from one end. It might not go through too easily straight away. In this case it has, but similarly to the other end, you just want to put it in through one end. You might have to go through the other end and give it a bit of a jiggle, just so everything lines up. And then you're going to take the spanner and the hex key, and you're going to use those just to tighten it up. You don't want it to be too tight, because if it's too tight, then it closes off the end, and for the sake of the calculations, we have assumed an open-ended tube, so that is tight enough for this purpose. And I'll just come to the other end, which has got it set up the opposite, so I'll just keep those around. It's not critical either way, whether you have the nut at the bottom or the top. Just tighten that up, and that seems to be tight enough there, so it's getting a bit of resistance. So I'll just put these down. The next step is to take the torque wrench, and you want to set it at the 100 Newton meters. Now this number's been chosen because it will give an angle that will be easily measurable by eye, but also it will only elastically deform the pipe, which is important. So there are digital torque wrenches, but the one I'm using at the moment is manual. The way you want to set it is there's a foot-pounds scale on one side and a Newton meter scale on the other side. You want to loosen off this bottom and then twist it until it lines up with the correct value. So this one doesn't have a side which fits exactly at the 100 meters, but the closest is 98, so you want to get it right on there. It's not too crucial if it's a little bit off, but you will get better results if you're as close to as possible. Again, they don't have to be exactly 100 as long as it's the same for each of the different cross sections. So before you actually start taking measurements, you want to just apply a bit of a load, and you can hear that there's a little bit of give in each of the ends. So that was one end, and that's just to allow any looseness in each of the joints to be taken out, so that it doesn't skew your measurements. So what you're then going to do is have a quick look at the value before the test has started. So I'll just take, so you can have a bit of a look at the compass, so protractor, and I've got it set up with 2 prongs so that you can see in between it. The value that I take for that is approximately 245. What you're then going to do is take the torque wrench, get down so you can see as you're twisting, and apply the load. And then take note of what the value was when it clicked, which was at the 100 Newton meter value. And finally, just check to make sure that it is still at the 245 degree value when you take off the pressure. The reason for this is that if it's not at the same value that you started with, your test is invalid. And the reason it's invalid is that if it hasn't returned to the same number, it's either deformed plastically or you could have had some give left to take out of the joints. So that test would need to be redone. You're going to repeat this at least 3 times for each of these pipe sections. For this pipe section. And then you're going to take the pipe off and put in the next one and repeat for all the tests.